Hi, and welcome to this quick review on dimensional analysis. This is a quick review for nursing students that are learning med-calc as a way to look at problems. It's a benefit that you don't need to memorize any formulas and just a really easy way for you to get the answers that you're looking for. So dimensional analysis, there's 5 steps. The first step is to identify the given quantity of the problem. This will make more sense when I give you some practice problems later. In other words, the given quantity can be considered the order. So if the provider orders, 325 milligrams of Tylenol, and they're asking you maybe how many milliliters you give, the given quantity would be that order or where your starting point is. With the wanted quantity, that is where you're ending up. So for example, in that last one that I just said, if you're giving 325 milligrams of acetaminophen or Tylenol, how many milliliters would equate to that 325 milligrams? So for that example, the wanted quantity would be milliliters, not milligrams. The unit path is everything that you need to use in terms of how to get there. I always think of it, you're using a map to get to where your destination is. So there may be different conversions that you have to do. In one factor, it's usually pretty simple, but as we go on, we'll have 2 and 3 factor where you might be going from mics to kilogram per minute, milliliters. You might be having to convert maybe pounds to kilograms. So this gives you a way that you can get to where you're going, if you will. You'll have to set up the problem to permit cancellation of unwanted units, and I'll show you how to do that in a moment here. And then after you've got your problem set up, you're going to multiply all of your numerators, which remember numerator up top, denominator down. So you'll multiply your denominators, and then you're going to divide the product of your numerators by the denominators to give you that numerical value of your wanted quantity. And if that seems really abstract, I'll give you some really concrete examples to help you understand. For my course, these are the conversions that I ask that my students memorize so that they know all of these. It will be extremely helpful to commit these to memory. So we'll, especially 1 liter being 1,000 milliliters, ounces to milliliters. With weights, a lot of times in the hospital, we deal with kilograms instead of pounds. You'll need to know how to convert kilograms to pounds. I always think if someone's overweight, they'll want to tell you their weight in kilograms because it's going to be a smaller amount. So that's 1 to 2.2 pounds. Grams to milligrams, milligrams to mics. 1 gallon is about 4,000 liters. 4,000 milliliters are 4 liters. So these are conversions that you would need to know. Teaspoon and tablespoon, I also require my students to know, so that 1 teaspoon is 5 and that 1 tablespoon is 15 milliliters. Okay, so let's get into some problems here. I'm going to get rid of my laser. I'm going to get my pen. So for this question, 1 liter equals how many ounces? Now, if we're using dimensional analysis, the first thing that you're going to want to do is determine what's the given quantity or what's the order. So in this question, the given quantity would be 1 liter. Okay, the question's asking you how many ounces are in 1 liter. So our wanted quantity is going to be in ounces. Now, conversions is that roadmap. Remember, how do we get to where we're going? So how are we going to convert liters to ounces? So I recommend creating a grid that looks like this, where you're going to use your given quantity here, which is the order, your wanted quantity, where you want to end up over here. So for example, in this one, the given quantity would be 1 liter, right? And our wanted quantity is going to be in ounces. Now to get there, as we showed on that previous slide, we're going to have to convert liters to milliliters and then milliliters to ounces to get what we want here, okay? When you set this up to get rid of unwanted quantities, they have to be adjacent to each other. So if you put 1 liter up top, you're not going to be able to eliminate that and get rid of it, and you're going to throw off your numbers. So please make sure when you're getting rid of your unwanted quantities that you have them adjacent to each other. And I really recommend my students to have a highlighter for these questions so that they can circle once they have what they want and they cross out what they can get rid of. So for this question, 1 liter, we know 1 liter is equivalent to 1,000 milliliters. We've now been able to cross out these two, not need liters anymore. And now we're left with milliliters. Now our wanted was in ounces, so we have to get rid of that. In that previous purple slide, I showed you that 1 ounce is equivalent to 30 milliliters. Now by setting it up this way adjacent, we're able to get rid of what we don't want, which is milliliters. And now we're left with ounces. Once it matches what your wanted quantity is, go ahead and circle it, and that'll help you out when you do 2-factor and 3-factor problems, just to keep yourself kind of organized. Now we're ready to do the math. So like I said earlier, step 4 was multiplying your numerators, which will be 1 liter times 1,000 milliliters times 1 ounce, which is 1,000. And then you're going to multiply your denominators. So 1 times 30. So basically all you're going to need to do is divide 1,000 by 30 to get 33.3 ounces, which is your answer. So pretty simple with 1-factor. I'm going to give you a couple more practice problems. I recommend pen and paper and doing this along with me, and you can always go back and practice on your own as well. So for this question, our order is meperidine, which is Demerol, 150 milligrams IV times 1 dose stat. That means right now. How many milliliters will you as the nurse administer? It does tell you here we're going to round to the nearest tenth. Okay, so our first step always is identifying where are we starting? What's our order? What's that given quantity? In this question, the given quantity is 150 milligrams of that medication, Demerol. So we're going to write on the first part here, 150 milligrams. Okay, the next step of our problem is figuring out where are we going? Where do we want to end up? I cannot fill all of this in until I know where I'm going because I might not set it up appropriately. So step 2 is our wanted quantity. You can see here, our wanted quantity is going to be in milliliters. Forgive my chicken scratch, okay? So I have milligrams and I'm going to need to convert to milliliters. If I look at this label here, it's kind of small, but you can see Demerol, what we have on hand is 100 milligrams in 1 milliliter. 100 milligrams, and it just says ml, so that you assume is 1, okay? I'm going to have to put my 100 milligrams below. Do you remember why? Because we need to get rid of that, and we can only get rid of milligrams until we have them adjacent. We know 100 milligrams that we have on hand is in 1 milliliter, okay? I've got scratched off what I don't want, and I'm going to circle my wanted quantity. Once I've done that, I know I'm ready to do math. So just looking at some simple math here, we know 150 milligrams times 1 is 150. We're going to divide that by 100, okay? So now you'll see we have 1.5 milliliters is going to be our answer. We got to make that point there so no one thinks we're giving 15 milliliters. There we go, 1.5 milliliters, and that's going to be equivalent to 150 milligrams of Demerol. Okay, so there's your answer. Now it says round to the nearest tenth. I don't need to do that. I've already got 0.5. It's already in the nearest tenth. Now, if my answer had been 1.67, I would have to round this up. So remember, anything greater than 0.5 or up, you round up. Anything less than 0.5 or less, you would round down. Okay? All right, let's do it again. And forgive me, I don't have a calculator. I'm going to have to bump these out while I'm doing it. So for this problem, our order is potassium chloride, 15 milliequivalents. That's what MEQ stands for. That's just a conversion factor that we use for electrolytes as they're dissolved in a liquid. So we've got our order is for 15 milliequivalents, so MEQs, okay? Now, where are we going in this problem? What's our step 2? We want to know how many milliliters to give. So over here, we're going to write milliliters, okay? Now, I need to throw in my conversion factors to get from MEQs to milliliters. If you look on hand, it's kind of hard to see, but it says 20 milliequivalents, MEQs, per 15 mLs. So below this, we're going to do 20 milliequivalents, okay? And that was in 15 milliliters, okay? So now I can eliminate my unwanted quantities. I want to get rid of those MEQs, and I want to circle milliliters. Now, since it matches, now we can start doing our math. So if you look at it, we can see we have 15 times 15, and then we're going to be dividing that by 20. Okay, so if you do this on your own at home, you'll know 15 by 15 is 225. Okay, and then we're just going to divide that by 20. And then you should get 11.2 to that point even bigger, so there's no mistake. 11.25 milliliters. Now, if we go back, it says we need to round to the nearest tenth. So with this one, because this one is greater than 0.5, it's going to be 11.3 milliliters is our answer. Okay, so hopefully that's pretty clear. Let's do one more just to make sure that you're feeling super confident. With this order, we have Unison, which is an antibiotic, 700 milligrams intramuscularly daily. So for our given quantity in this one, we're going to place over here 700 milligrams. Okay, the question's asking us, how many milliliters are we going to give this patient? Okay, so we're going to give our wanted quantity in milliliters. Okay, now we've got to fill some things in here. It looks like on hand, you've got, picture a little vial of powder that's labeled 3 grams. Okay, so that gram is actually your antibiotic. Now, we would never be able to give someone intramuscularly a powder, right? So what you would do as the nurse is you're going to add some sterile water to that vial and shake it up. Okay, after you've shaken it up, you now have 2 grams and 5 milliliters of fluid. So this kind of is extra information that if you're actually doing this, you need to know. But for this problem, we don't need to put that anywhere. What you care about is your final yield, which was 2 grams and 5 milliliters. Okay. Now we have a problem that was given us milligrams. So our first step is going to be converting milligrams to grams. Okay. So if you remember, we have to put milligrams below so that we can get rid of it. If we put it up here, our numbers would be off and we couldn't eliminate that. Now we're going to have how many grams per milligram? We'll know that grams are larger, so we have 1 gram is equivalent to 1,000 milligrams. Okay, that milli being 1,000. Now that I've done that, I can eliminate my milligrams, but I have grams here, and that doesn't match where I'm going. So the next step is going to be get rid of that gram by putting in what we have on hand, which is 2 grams per 5 milliliters, right? Because we just shook it up and we're about ready to get our sterile needle, draw it up, and inject it into the patient intramuscularly. So we've got 2 grams and 5 milliliters, okay? Now I can eliminate my grams. Everything else is eliminated. I can go ahead and circle that milliliters because it matches where I'm going, right? So now your next step as the nurse is going to be multiplying 700 times 1 times 5, and then dividing that by 1,000 times 2. I do encourage my students, especially if they've got larger questions, you can eliminate zeros, but remember whatever you do on the bottom, the denominators, you also have to do for the top. So for example, if you want to deal with smaller numbers in your calculator, we can scratch off these 2 zeros and leave it with 10, and scratch off these 2 zeros and leave it with 7. Okay, either way is correct. You'll still get the same numbers. I think there's less margin for error when you're dealing with smaller numbers on a calculator versus, tens of thousands or if not millions. Okay, so we'll pretend that you did decide to get rid of these 2 zeros and those 2 zeros. So now all you have to do is multiply 7 times 1 times 5, which we all know is going to be, let's put it up here so I don't confuse you, 35. And I'm going to erase that just to get rid of it. Okay. And now we know 10 times 2 is 20, right? So for this one, we have 35, which was 7 times 5, divided by 20, which was 10 times 2. Okay, so now if we look at that on our calculator, 35 divided by 20, you're going to get 1.75 milliliters. Just like in that last question, it said round to the nearest tenth. So because this is greater than 5, it is going to be 1.8 milliliters. And that's all I've got for 1 factor. I hope that was helpful. Please reach out and follow my channel for any more tips. I'll be coming out with 2 factor and 3 factor soon. Thanks so much.